All right, so this is a screencast about the hobo problem, number 11. It says you've got a hobo sitting on a track 15 meters behind the caboose of a stationary train. When he sees the train begin to move, he leaps up and runs after it. The train has an acceleration of 0.7 meters per second every second, and the hobo runs with a constant velocity of 5 meters per second. All right, so let's just model their motion real quick. Hobo, pretty simple motion. He just moves constant velocity of 5 meters per second. So there's the hobo's motion. Okay. The train is actually a constant acceleration, and the train is speeding up in a positive direction, let's say. So we've got the train starting from rest and speeding up, right? The acceleration, since we're given information about acceleration, I should look at that graph. Acceleration is meters per second squared times measured in seconds. And the train has an acceleration of 0.7 meters per second every second. So I'll write that. And what else do we know? Well, that means this area here, this rectangle, in time t, the change in velocity for the train is going to be 0.7 t. That's our change in velocity, right? Which means the height of this triangle is going to be 0.7 t, right? And if this is our time t there, then this triangle will have an area 0.7 t squared, right? Divided by 2, and that's our displacement. That's our change in position. All right? So I suppose we have to figure out some logical relationship between how far the hobo travels and how far the train travels. So the hobo's distance traveled, you'll notice he has to go further because he has to catch up to the train. So the hobo's distance traveled has to be the train's distance traveled plus the amount the hobo was behind, which is 15 meters, right? So I'm thinking of my equation in terms of distances. Now I can just start plugging things in, I guess. Hobo's distance traveled, I should have said that, is going to be 5 times t, right? The 5t has to equal, let's see, the train's distance traveled is going to be 0.7 t squared over 2, right? And then I'm adding 15 to that. And I should rearrange things to make it look pretty. 0.7 t squared over 2, right? Minus 5t plus 15 has to equal 0, right? So I get 0.35 t squared minus 5t plus 15 equals 0. And then I actually cheated, man. I'll be honest with you. I just did a Google search for quadratic equation calculator, and I found my two roots that way. So you should get two solutions for time. You get about 4.3 seconds. Well, that means you get t minus 4.3 as one of your solutions. So t is about equal to 4.3 seconds. And the other solution, you should get t minus 10, right? So this means that this factor or that factor can be equal to 0. So one or the other or both are equal to 0. So t is 4.3 seconds. Or, it's actually and or. T equals 10 seconds. So in some cases, one of these is a solution. But in this case, it's kind of interesting because it appears as though the hobo is going to have two chances to catch this train. If I do my position time graph, right? Be kind of a nice time to show you that. The train has a head start. So the train starts at 10-meter position. The hobo moves constant speed, constant velocity, like this meters and this seconds, right? Now, this is the hobo. Now the train starts off slow and slowly speeds up. And there's our two chances right there. This was 4.3. And this time here was 10. So that's pretty cool. Pretty cool problem. I like this problem. Interesting. And you could actually find out where they are. The easiest way is to use an equation for the hobo's motion. The hobo's position is going to be the hobo's velocity, which, if we look at the problem again, the hobo's velocity was 5 meters per second. The hobo's velocity is 5 meters per second times time, and we're having the hobo start at 0. So position is 5 times 4.3. So that's the position when hobo gets his first chance, right? 5 times 4.3. So that's 21.5. And that's meters, since 4.3 is seconds, 5 is meters per second. This counts to give us meters. And his other chance, so this is his first chance. His second chance is going to happen at 5 times 10, right? So his second chance is going to happen at 50 meter position. And I'll just circle that and write second chance to catch the train, to jump on the train. Now that was a pretty cool problem. You should probably try the number 12. That's kind of neat. Slightly different. And anyway, I hope this helps. Hope you have a good day. And thanks for watching.